I'd like to hear your thoughts.
If you'd like to hear it, I can sing it for you.
Yes, Al. Sing it.
Build by the science guy.
We are experiencing technical difficulties. Please don't.
I'm Kevin Chilton. I've flown in space twice, both times aboard the Apollo Endeavour.
2, 1, 0.
The challenges of breathing in space are, first of all, taking up enough air with you to live and breathe in the atmosphere up there. And most of our missions are limited by the amount of air we take up in the shuttle. For inside the space shuttle environment, where we keep 14.7 pounds of pressure, we bring up nitrogen and oxygen to breathe, just like we're breathing in this room right now. And we mix those two gases together and breathe them. And as we consume the oxygen, eventually we run out of that and it's time to come home. In the space suit, when we go on a spacewalk in the spacesuit, we also have that limitation of how much oxygen we take in the suit. And we typically carry enough oxygen in the suit to be outside for about 8 hours. These particular spacesuits we only wear when we go outside the space shuttle. So it'd be more accurate to call this a mini spaceship, really, than just a spacesuit, because this suit has to perform all the functions to keep a human being alive that the space shuttle has to have. Turns out when you work in a spacesuit out in space, since it's a vacuum outside, we have to pump the suit up with pressure on the inside. And when we do, if we were to pump this suit up with the same amount of pressure in this room here of 14.7 pounds per square inch, the suit would be so rigid, it would be such a tough balloon, you couldn't move in it. You'd be stiff. So we only pump the suit up to about 4.5 pounds of pressure. And that way the astronaut is able to bend his arm against the pressure of the suit. But we can't breathe 4.5 pound pressure air. So what we do to get around that, to provide enough oxygen to our body, is we breathe pure oxygen inside this spacesuit at lower pressure. So you have all the things necessary, the oxygen supply that you need to breathe, the equipment to remove carbon dioxide from the air that you're breathing, the cooling that you need in the suit to keep your body at the right temperature when you're outside working. All of that is packaged in one neat little package here in the back of this spaceship. We could not take any of these adventures in space were it not for the scientists and engineers who solved the problems of allowing people to live in a vacuum and work in zero gravity.
It's a beautiful night for baseball. You know, the weather here on Earth is no problem. But if you go to another planet, say Jupiter, the weather can be pretty tough. Hey, sir, excuse me, may I have a hot dog on a Jupiter roll? You see, this is the planet Jupiter, and there's a big red spot. It's a swirling, turbulent gas cloud that's been there for several hundred years. You know, it's several times the diameter of the Earth. Yeah, can I have the red hot? Yeah, see, this is a red hot, and that's a red spot. And you know, there were these comets that came in and slammed into the surface, leaving these big Earth-sized impact craters on the still swirling around. And Jupiter has these large striped bands of weather patterns that are been there for hundreds of years and are fascinating to study from Earth. It's just a wonderful place, Jupiter. Oh. Live on a planet. There are 9 of them altogether. Mercury, Venus, there's Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And don't forget, there's 61 moons. about moons, you might start with this one. And when you think about science, you might start with... Bill Nye the Science Guy. Well, that's our show. Thanks for watching. If you'll excuse me, I've got to get back to work. Check this out. Awesome. Let's go. Who's with you?